What are nitrous oxide levels doing? And what is its role with respect to climate change? Well, study finds human-caused nitrous oxide emissions grew 40% from 1980 to 2020, greatly accelerating climate change. Hello friends, Jim here. I will get back to this diagram later on. We'll look at it in greater detail. Emissions of nitrous oxide, which is a greenhouse gas that is more potent than carbon dioxide or even methane. And we know methane is more potent than CO2. So nitrous oxide is more potent than methane. Ouch. Continued unabated between 1980 and 2020, a year when more than 10 million metric tons were released into the atmosphere, primarily through farming practices, according to a new report by the Global Carbon Project. Agricultural production accounted for 74% of human-driven nitrous oxide emissions in the 2010s, attributed primarily to the use of chemical fertilizers and animal waste on croplands, according to the report Global Nitrous Oxide Budget 2024, led by researchers from Boston College and published in the journal Earth System Science Data. In an era when greenhouse gas emissions must decline to reduce global warming in 2020 and 2021, nitrous oxide flowed into the atmosphere at a faster rate than at any other time in history. We've heard that before. The international team of researchers reported, on Earth, excess nitrogen contributes to soil, water, and air pollution. In the atmosphere, it depletes the ozone layer and exacerbates climate change. Agricultural emissions reached 8 million metric tons in 2020, a 67% increase from the 4.8 million metric tons released in 1980, over a 40-year period. According to the study, the most comprehensive study of global nitrous oxide emissions and sinks, produced by a team of 58 researchers from 55 organizations in 15 countries. Nitrous oxide emissions from human activities must decline in order to limit global temperature rise to 2 degrees C as established by the Paris Agreement. Good luck, said the report's lead author, Hanken Teen, of the Schiller Institute Professor of Global Sustainability at Boston College, BC. Reducing nitrous oxide emissions is the only solution, since at this point, no technologies exist that can remove nitrous oxide from the atmosphere. The concentration of atmospheric nitrous oxide reached 336 parts per billion, with a B, in 2022, a 25% increase over pre-industrial levels that far outpaces predictions previously developed by the IPCC. The IPCC strikes yet again, underestimating stuff. Almost a modus operandi. This emission increase is taking place when the global greenhouse gases should be rapidly declining towards net zero emissions if we have any chance to avoid the worst effects of climate change. Thermal inertia, pipeline warming, hello. The world's farmers used 60 million metric tons of commercial nitrogen fertilizers in 1980. By 2020, the sector used 107 million metric tons. That same year, animal manure contributed 101 million metric tons for a combined 2020 usage of 208 million metric tons. That is a crap load, literally. The unfettered increase in a greenhouse gas with a global warming potential approximately 300 times larger than carbon dioxide presents dire consequences for the planet. Well, duh. Drawing on millions of nitrous oxide measurements taken during the past 4 decades on land and atmosphere, freshwater system, and the ocean, Teen said the research has generated the most comprehensive assessment of global nitrous oxide to date. And that is a major undertaking, so they are to be commended for that. Let's be clear on that. The researchers examined data collected around the world for all major economic activities that led to nitrous oxide emissions and reported on 18 anthropogenic and natural sources and 3 absorbent sinks of global nitrous oxide. The top 10 nitrous oxide emission producing countries are China, India, the United States, Brazil, Russia, Pakistan, Australia, Indonesia, Turkey, Canada. Well, China and India, their combined population is about what? 1/3 of global population? Some countries have seen success implementing policies and practices to reduce nitrous oxide emissions. Emissions in China have slowed since the mid-2010s, as have emissions in Europe during the past few decades. In the U.S., agricultural emissions continue to creep up, while industrial emissions have declined slightly, leaving overall emissions rather flat. Natural sources of nitrous oxide emissions from soil, fresh and salt water have remained stable. Established in 2001, the Global Carbon Project analyzes the impact of human activity on greenhouse gas emissions and Earth systems, producing global budgets for the 3 dominant greenhouse gases, CO2, CH4, and 2O, that assess emissions and sinks to inform further research policy international action. Improved agricultural practices that limit the use of nitrogen fertilizers and animal waste can help reduce greenhouse gas emissions and water pollution. Teen said there is need for more frequent assessments so mitigation efforts can target high-emission regions and activities. The growth rates of atmospheric nitrous oxide in 2020 and 2021 were higher than any previous observed year and more than 30% higher than the average rate of increase in the previous decade. N2O, nasty stuff. Let's take a look at this diagram. Like carbon dioxide and methane, the greenhouse gas nitrous oxide plays a significant role in global warming. While naturally occurring, it is also produced primarily by farming activity. Human-driven nitrous oxide emissions flowed unabated between 1980 and 2020, with more than 10 million metric tons released into the atmosphere in 2020. So, you will see this is called the Global N2O Budget, and they list anthropogenic sources, change in atmospheric abundance, and natural sources. All these values given with the range, and this is like an average, are in teragrams of nitrogen per year. Okay, TG, nitrogen, or million metric tons per year. The prefix tera is 10 to the 12. So 1 followed by 12 zeros. That's how much. So 3.9 times 10 to the 12, 0.8 times 10 to the 12, or 8 times 10 to the 11. Okay, and so on. So as we can see here, agriculture and waste is the largest of the anthropogenic sources. Fossil fuel and industry, nitrogen deposition, freshwater, and coastal. So these are the top 3 sources for anthropogenic releases. Biomass burning, and then we have a slight drawdown, like this arrow down. This is an arrow down, so there's a slight drawdown from, what plants, nitrogen fixation, right? Nitrogen is fixed in the roots before it, is turned into nitrate and nitrite before the plants can utilize it. So it is a drawdown and a part of the nitrogen cycle. Hey, deposition, freshwater, and coastal, biomass burning. So I'm wondering if the deposition includes the animal manure. Now, what are the natural sources? Soils, freshwater, and atmosphere. Again, part of the various, like the nitrobacteria, all the various bacteria that are part of the nitrogen cycle. You have the denitrifying bacteria, nitrogen fixing, and so on and so forth. I could do a whole video on the nitrogen cycle. Hell, it's a whole week or two in ecology classes on the nitrogen cycle. But in essence, we have certain bacteria that will take the nitrogen found in compounds, break it down, and then release nitrogen gas back to the atmosphere. And in this case here, you have other bacteria that will release N2O back to the atmosphere. There might be some atmospheric or chemical sink, right? Which is 13.4. So what we have here is you take the 7.1 and you have the oceans, the 4.7. Okay. You add that up and you get 11.8. So there's your natural sources. So they obviously did not subtract out the 13.4 from this. But the natural sources of N2O into the atmosphere is 11.8. If you add these up, you get 6.5. And remember, these are teragrams of nitrogen, right? So you add these up. So if you look at the total here, we're looking at 18.3 or so. So then you take the 18.3, you subtract out the 13.4 or so, and that should leave you with the 4.6 for the net increase into the atmosphere. Right. I'm doing this, if I did my math correctly, or arithmetic correctly. Now, they're talking about soils and so forth. It is not clear to me if this includes the N2O that's released from the thawing permafrost. And the same thing here for the oceans, where you have the the release of the methane bed and so on. Well, you have permafrost on the oceanic shelf as well. They also release N2O. So to me, it's not really specified if it includes the N2O release from the permafrost that occurs in the polar regions and in the polar oceanic regions, such as the shelf regions in the Arctic Ocean. But anyway, so that's how they arrive at these numbers here. You add up these four things here, subtract out this here. So you take this and this, right? You subtract that from the total of these four items and these two items, and you get this 4.6. So there's your budget. But it's increasing. And these are a range of values here over the years. So, farming practices lead to increased global warming. And let's not discount cow flatulence. The methane they release is a significant contributor. And as we put more and more people on the planet, we need more and more land to produce more and more food, which means we need more and more farming practices. And to increase the yield to feed more and more people, we probably have to use more and more fertilizers, adding to more and more N2O into the atmosphere. See the nice little positive runaway feedback loop we humans create? Anyway, it's a problem, and a big one. So, until next time, thank you for your time.